This is question 53 from section 1.6. The question reads, square root of x plus 3 is equal to the square root of 2x plus 8 minus 1. Essentially, the reason why this problem is so challenging is because you have two binomials under two separate square roots. So it's going to end up getting a little bit messy. So one of the first things that you should ask yourself is, okay, I want to start clearing out these square roots. So the first method of attack is to square both sides. The nice thing is that the square and the square root, because they are inverses of each other, they're going to cancel each other out. But we need to spend a little bit of time with what's going on the right-hand side. So we have the square root of 2x plus 8 minus 1 squared. Now, what you want to do here, and I'll note this as an aside, so that just means I'm kind of thinking off to the side for a little bit. This is actually the square root of 2x plus 8 minus 1 times the square root of 2x plus 8 minus 1. So it looks like a foiling problem because it is 1, but it looks a little bit intimidating because you have such a large first term, this entire square root. So once you kind of recognize that it's very similar to previous problems, it becomes a little bit less mystical, I guess. So we always do our FOIL as we usually do, so our first terms. So this would give you 2x plus 8, that root, squared. Then we do our outer terms. So this is just a -1 times the square root of 2x plus 8, followed by our inner terms. Again, this is another -1 times the square root of 2x plus 8. And then lastly, we do our last terms, which is going to be -1 times -1, or a positive 1. So from here, we go ahead and clean it up. So again, we can argue that the square root and the square are inverses of each other, so they take each other out. And what we had in the radicand, or as the radicand, just drops out. Notice here that you do have like terms. So this actually becomes -2 times the square root of 2x plus 8, and then we have a plus 1. So really the last thing that you can do is note that you do have like terms. These are both constant values, so I am permitted to combine them, because let's try to make this look as nice as possible. Okay, so this value will go in for what I have on the right-hand side of my equation. So I'm done with my aside. So I have x plus 3 is equal to 2x plus 9 minus 2 times the square root of 2x plus 8. It looks a little bit better. It's not fantastic, but we can continue to do more because we have freed a little bit more of the values, so we can go ahead and say maybe start combining like terms again. So I'm going to subtract 2x from both sides, and I'm also going to subtract 9 from both sides. So again, I'm going to try to isolate that radical as best as I can. So this is going to leave me with a -x minus 6 is equal to -2 times the square root of 2x plus 8. Again, it's looking a little bit better. I have freed more of the terms, and therefore I am now free to work with them. So again, the issue is here is that, well, I still have this radical. So what I'm going to do is I'm going to square both sides in an attempt to free them. So here, again, we're going to have to FOIL this out. So I'm just going to go ahead and show you what the final result will be on this side. If you're not sure, or if you want to, I would suggest pausing the video and foiling this out and making sure that it actually matches with what I have. So if you were to FOIL this out, you would have x squared plus 12x plus 36. And on this side, recall that since you have a product, you are safe to square the first factor of your product and the second factor of your product. So this becomes a negative 2 squared, which is going to give you a positive 4, because negative 2 times negative 2 will result in a positive value. And then this is going to be times your quantity 2x plus 8. Again, the same argument that we have made in the previous examples. If you're squaring something that is square rooted, the inverse between the root and the exponent happen, and then the radicand just drops out. So this permits me now to write this. My left-hand side of the equation is going to be left unchanged in this case, and I'm going to distribute that 4 to each of those terms. So now I have an 8x plus a 32. Okay. In previous problems that we've looked at, we always want to combine like terms. And if you notice that on the left-hand side, it's starting to, or it is a quadratic. And when I move, or when I remove an 8x from both sides, and I remove a 32 from both sides, I still have a quadratic. So now I have x squared plus 4x plus 4 is equal to 0. Now, hopefully you guys appreciate the fact that we took something that was so cumbersome initially with 2 square roots, and we boiled it down to a rather simple looking quadratic. So we just want to go ahead and factor this. And again, if you've had enough practice with this, we know that we can split x squared into an x, and an x. And we can try and split, say, 4 into plus 2 and plus 2. So again, if you want to check this, x plus 2 times x plus 2, we should get that it will equal x squared plus 4x plus 4. So if we FOIL this, we do in fact get that back. So we did, because we get an exact match, we did FOIL this correctly. Or sorry, factor this correctly. Excuse me. So from here, we can say, okay, x plus 2 is either equal to 0 or x plus 2 is equal to 0. I understand that we are repeating the same thing here, so we really only need to focus on one of them. So we'll subtract 2 from both sides, and we get x is equal to negative 2. And this is our solution. Again, you can go ahead and check your work. So we'll do a final check here. And we'll go back to our original problem. So we have the square root of, in this case, we'll do negative 2 plus 3 is equal to the square root of 2 times negative 2 plus 8 minus 1. And from here, we would clean this up. This is the square root of 1. This is going to be negative 4 plus 8 minus 1. This is 1. This is 4 minus 1. 1 is equal to, the square root of 4 is 2, and 1 is equal to 1. So this checks out. This is our solution, and we're good.